All right, so let's go over this. Last week, I told you there were 4 different types of sublevels. We have S, we have P, we have D, and we have F, okay? Now, I told you that each one has a certain number of orbitals. How many orbitals for the S? 1, okay? So I'm going to put a line up there. How many P's are there? 3. Okay, there we go, 3 P's. And how many D's? 5. Okay, 2, 3, 4, 5. And F's? 7. Okay, wonderful. Okay, so we have S, P, D, and F. Now what we're going to do is we're going to take an atom, okay? And each atom has what we call those energy levels. And each energy level has a number, okay? Represents the number of what we're looking at. This first one would be what? 1. This one would be? 3. And this one would be? 3. Okay. So the reason why I'm saying this is because what we're going to do is, let's say we're looking at an atom and it has 7 electrons. Those 7 electrons are within some of these energy levels. So the number, let's say I have a 3s2, like that. What this number represents is the energy level that we are looking at, okay? The letter, just like in your packet, represents the type of orbital. Now, in your packet, it represented the type of room. Either it was sunny or either it was pink, okay? And then this number in your packet represented the number of people that were in that room. Well, this number represents the number of electrons that are within that orbital, okay? So what we're going to do is we're going to look at orbital filling. And what we're doing is filling out the orbitals for all of the electrons for that element. So let's take a look at the first element, boron. How many electrons does boron have? Look at your periodic table if you have it out. 5. Okay? And we're going to put 5 electrons here. Okay. Now, how do we know what goes first when we start building our configurations? Well, on the slide where I told you the arrow where it has all of these, and I'll put it right up here, okay? It has a 1s, a 2s, then it keeps going down, 4s, and then it goes 2p, 3p, and then 4p, and then goes on from there. Now, the arrow starts on the very top, and this is the format. This is the pattern. We're going to start where the first arrow starts on the very top. And the direction means we're going to move this way. So what the first arrow is covering the 1s. Then the idea is then once we finish there, then we're going to go to the next arrow, and then we're going to move on to our 2s. When we're done there, then we're going to follow the third arrow, goes through 2p, and then it goes through what? Okay. So here's the idea. You're going to use this as a guide to help you fill the electrons within the orbitals. So we have 5 electrons that boron has that we need to account for. So we're going to fill in the first one. That's a 1s. I'm going to put a 1s, and I'm going to put 1 line because we know that the s orbital only has 1 type of orbital. How many electrons can it hold? 2. Okay, here's one of the rules. Now, according to the first principle that you wrote in the notes that was on the slides is off-bow principle. An off-bow principle states that you always start low energy first. And low energy would be starting with the 1s. Just like in the house in your packet, always start at the bottom. We always start at the bottom the same way here with the configuration with the 1s. Second principle, the Pauli exclusion principle states that you have to have we have 2 different types of spins. Okay, so here's the idea. Electrons, when they're within that orbital, one of them can be within the upper spin, a positive spin, and then one in a negative spin. So the way we depict that is by, like in your packet, either an arrow pointing up represents the positive, and then the pointing down represents the negative. Just so you know, I go ahead and do it this way. It's the same representation. You can choose whichever you want. So here's the idea. I'm going to always, according to the third principle, which is Hunt's rule, we're going to go ahead and fill in the positive spin first and then the negative spin. Okay? You can use complete arrows or you can have arrows like I did. It's your choice. Now, we need to account for 5 electrons. So far, we only have 2. So, what comes after the 1s? The arrow now points to the, so we're going to put a line, since in S only holds one type of orbital, and we're going to go and put it to S. The 1 and the 2 is only showing you, it's only telling you that now we are looking at the second energy level. The first shell, I've told you in your models, it can only hold up to 2 electrons. That's why we only have 2 electrons in the 1s. Okay? In the second energy level, okay, we can have up to 8 electrons. And that's where it comes. Now we're going to show you. This can hold up to 2 electrons. After the 2s, what comes next? 2p. But for the p's, there has to be 3 lines. Okay? That doesn't mean you're going to fill them all. You just have to represent that there are 3 orbitals in every p. Okay? Now notice, we only need 5 electrons for boron. We have 1, 2, 3, 4. So the only one we're going to do is the first positive spin, looking upward, first electron, and that's it. Why do we stop there? Because boron only has 5 electrons. Okay? Now notice though, in the first energy level, there's only 2 electrons. If we filled them all, how many electrons total would we have? If we filled the 2p completely. No, just these 2. 8. How many electrons did I tell you the second energy can hold? 8. Okay, that's what we're saying. Okay, so now sodium. Let's do sodium. Sodium has how many electrons? 11. Okay, all right, so now we're going to do it again. We start from the lowest energy, which will always be the 1s. So we put 1s and one line to represent that s, okay, only holds one type of orbital. We have how many electrons? 2. 1 upward, always the upward spin. Downward. Then after the 1s comes the 2s. How many will we put in here? 2, up and down. Then we have, what's after 2s? 2p, 3 lines. And we'll put 2p. Okay. Now, I need 11 electrons. So this is how you fill out the p's. Okay. One of the principles, one of the rules states that the same spin must be filled first. And we always fill it with the positive. So we have 1, 2, 3, 4. Watch this. 5, 6, 7. Notice I filled my positive spins first, and then I go back down and fill in my negative spin. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's happening? We need one more. So what comes after 2p? 3s. How many lines am I going to put for this one? 1, because it's still in S. 1 line, okay, to represent my 1 electron. Total, you count the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 electrons represented here. Got it? Okay, I'm going to give you a few minutes to go ahead and do oxygen and argon.